Welcome to Get Your FRQ On. This question is from 2008, Form B. It's question 4, and it is not calculator active. In the question stem, we have two functions, f and g. F is defined as an integral, and g of x is defined as f of sine of x. In part A of this question, we are asked to find both f prime of x and g prime of x. By the fundamental theorem of calculus, f of x equaling the integral from 0 to 3x of square root of 4 plus t squared dt implies that f prime of x is 3 times the square root of 4 plus quantity 3x squared. By the chain rule, g of x equals f of sine of x implies that g prime of x is f prime of sine x times cosine x. Using what we know about f prime of x, g prime of x is 3 times the square root of 4 plus 3 sine x squared times cosine x. In part B of this question, we are asked to write an equation for the tangent line of y equals g of x at the point when x equals pi. From part A, we know that g prime of x is 3 times the square root of 4 plus 3 sine x squared times cosine x. Evaluating g prime at pi, we get 3 times the square root of 4 plus 3 sine pi squared times cosine of pi, which turns out to be 3 times the square root of 4 times negative 1, which is 3 times 2 times negative 1, which is 6 times negative 1, which is negative 6. And finding g of pi is f of sine pi, which is f of 0, which is the integral from 0 to 3 times 0 of square root of 4 plus 3 times 0 squared dx. And since that integral evaluates to 0, the equation for the tangent line of y equals g of x when x is equal to pi is y equals negative 6 times the quantity x minus pi. In part C of this question, we are asked to write an integral expression for the maximum value of g on the closed interval from 0 to pi and to provide justification. So the maximum value of g should occur at either x equals 0, x equals pi, i.e. one of the endpoints, or some value of c between 0 and pi such that the derivative of g at c is equal to 0. Setting g prime of c equal to 0 would imply that c is equal to pi halves. Evaluating g of c, which is really just g of pi halves, we have the integral from 0 to 3 times the sine of pi halves of the square root of 4 plus t squared dt, which will be the integral from 0 to 3 of the square root of 4 plus t squared dt, and we note that that should be positive, so it is greater than 0. However, we still need to check the endpoints, g of 0 and g of pi. Doing a quick calculation yields that g of 0 and g of pi are both equal to 0. This allows us to conclude that the maximum value of the function g on the closed interval from 0 to pi is the value from whatever that integral is, the integral from 0 to 3 of the square root of 4 plus t squared dt. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.